Picture this. You're asked to do tech support and repair a broken computer. Sounds standard, right? But now, imagine that computer is hurtling through space at over 38,000 miles per hour. It's built with literal 1970s technology, and it's located so incredibly far away that a radio signal, traveling at the speed of light, takes nearly an entire day just to reach it. Welcome to this explainer. Today, we're unpacking one of the most high-stakes, mind-bending technical rescues in human history. We're going to look at exactly how NASA engineers managed to hack and save humanity's most distant spacecraft, Voyager 1.
Okay, let's just try to wrap our heads around the sheer, massive scale of the distance we're talking about here. 15 billion miles. Voyager 1 is currently navigating the freezing, lonely edge of interstellar space, way beyond the protective bubble of our sun. To really put that into perspective, this spacecraft has completely left our solar neighborhood. It is, without a doubt, the farthest human-made object in existence. And it was out there in that unfathomable dark where our crisis suddenly began.
Because on November 14, 2023, the absolute unthinkable happened. After decades and decades of faithful service, Voyager 1 suddenly fell silent. Well, actually, scratch that, it wasn't entirely silent. Instead of sending back its usual, meticulously gathered scientific data, it just started transmitting this chaotic, meaningless stream of binary code. It was just sequences of zeros, or repeating numbers like 377. Complete and utter gibberish. You can imagine, this was a truly terrifying moment for scientists back on Earth. It really looked like the spacecraft, which had survived the brutal environment of space for over 4 decades, might finally be lost forever.
Hacking a vintage computer? To really appreciate how NASA solved this, we first need to look at the unbelievable constraints these engineers were up against. They weren't just trying to fix a machine in the void, they were trying to hack a genuinely vintage computer. We're dealing with true 1970s tech here. Voyager 1 launched back in 1977. Its scientific data is literally encoded on old-school digital 8-track machines, and it broadcasts using a 22.4-watt radio transmitter. For context, that's roughly the equivalent of the tiny light bulb inside your refrigerator. By the time that signal crosses 15 billion miles to reach us, the power is reduced to 0.1 billionth of a watt. That signal is so incredibly weak that NASA has to use its massive deep space network, which is this array of gigantic 70-meter radio antennas spread all across the globe, literally just to hear it whisper.
The specific point of failure ended up being something called the Flight Data System, or FDS. Basically, the gibberish wasn't an antenna problem. It was a corrupted memory chip inside this specific onboard computer. The FDS is essentially the brain responsible for packaging up all the science and engineering data before transmitting it home. And a single chip had failed, effectively lobotomizing the spacecraft's ability to communicate coherently with Earth.
And here is where the constraints become, honestly, just claustrophobic. 69.63 kilobytes. That is Voyager 1's total memory capacity. To put that in modern terms, that is barely enough space to store a single low-resolution JPEG photograph on your laptop. That tiny sliver of data is the entirety of the digital real estate the engineers had to work with to somehow implement a fix.
And this really highlights the astronomical odds of pulling off this hack. Voyager's computers can execute about 81,000 instructions per second. If you pull the smartphone out of your pocket right now, that phone is roughly 7,500 times faster than the computer running humanity's most distant outpost. They had to reprogram this incredibly limited, sluggish system from billions of miles away, all without triggering some other catastrophic failure. But wait, it gets even more stressful, because there was a ticking clock on this rescue mission. Voyager 1 is running out of power. It relies on a 46-year-old battery system, specifically radioisotope thermoelectric generators, and they are slowly decaying. Because of this continuous power drain, NASA is expected to begin a phased shutdown of the remaining instruments around 2025, meaning every single day spent trying to fix this computer was a day of lost science that they could simply never get back. So let's break down the absolute genius solution the team came up with. Since they obviously couldn't just fly up there and physically replace the dead memory chip, they had to bypass it. Step 1 was identifying and isolating that corrupted section. Step 2 was the really tricky part. They took the essential code that lived on that dead chip, chopped it up into smaller pieces, and then carefully tucked those fragments into other pristine, unused sections of that tiny 69-kilobyte memory bank. And finally, step 3, they had to transmit these new operating instructions completely blind, just hoping the spacecraft's backup systems would accept the digital transplant.
The 45-hour pan.
Sending the command, though, was really only half the battle. Then came the wait. After months of terrifying silence, from November 2023 all the way to April 2024, the team painstakingly developed and tested this patch. Finally, on April 18th, they took a massive collective breath and transmitted the new memory code out into the void.
Now, because Voyager 1 is so unfathomably far away, radio waves, which, remember, travel at the literal speed of light, take a full 22.5 hours just to reach the spacecraft. That is nearly a full day of traveling at 186,000 miles per second just for the instructions to arrive at the door.
And then, the engineers had to sit in agonizing suspense for another 22.5 hours just to hear a response back. For 45 hours, the entire mission control was practically holding their breath, waiting to see if their ultimate long-distance surgery had killed the patient or saved it. Every single attempt was a terrifying step into the complete unknown. But then, on April 20th, 2024, something absolutely incredible happened. The Deep Space Network caught a signal. And it wasn't gibberish. It was clean, clear, perfectly formatted telemetry data. The hack was entirely successful. Against all astronomical odds, this 46-year-old pioneer phoned home, proving once again that human ingenuity can reach across 15 billion miles of empty space to fix a broken computer.
A cosmic legacy rescued.
Now you might be wondering, why pour months of agonizing work into an ancient probe that is already running out of power anyway? Well, to answer that, we have to look at what was actually saved. This spacecraft didn't just fly through the dark, it completely rewrote our solar system's history. It captured the very first active volcano ever seen beyond Earth, erupting on Jupiter's moon Io. It discovered totally new moons and a unique system of rings around Jupiter. It revealed that Saturn's moon Titan actually has a dense, opaque atmosphere. And, of course, in August of 2012, it became the very first human-made object to cross the heliopause and enter interstellar space. It taught us that the plasma between the stars is actually denser and colder than the plasma inside our own solar system.
It has been beautifully described as a silent wanderer in the cosmic sea. It has braved the dense, freezing plasma of the interstellar void farther than any human artifact has ever gone. It is quite literally acting as our ultimate scout in the uncharted darkness of the Milky Way.
But perhaps its greatest cultural contribution came back in 1990. At the suggestion of the legendary astronomer Carl Sagan, Voyager 1 turned its camera backward and took one final photograph from 6 billion kilometers away. In it, Earth appeared as a tiny 0.12-pixel pale blue dot. Sagan reflected on this image, noting that it profoundly emphasized our responsibility to cherish and preserve our only home. It is a stunning legacy of perspective, and thankfully it was saved from just fading into an unresolved glitch.
The final interstellar journey.
So even with the successful hack, we do have to prepare for the inevitable. Voyager 1's active mission is drawing to a close, but its physical journey is far from over. Bolted to the side of the spacecraft is a gold-plated copper phonograph record. Even when the power finally fails and those transmitters go permanently cold, Voyager carries this incredible time capsule. It contains 115 analog-encoded photographs, greetings in 55 languages, the sounds of Earth like whale songs and a mother's kiss, and 90 minutes of music. It's a literal interstellar message in a bottle, designed for any extraterrestrial intelligence that might one day cross its path.
As for its ultimate destiny, well, the instruments will likely begin shutting down around 2025 just to conserve its last trickles of power. From there, it drifts. It'll take roughly 30,000 years just to traverse the Oort cloud at the outermost, icy edges of our sun's gravitational reach. And in the year 4272 AD, nearly 38,000 years from now, it's projected to approach within 1.7 light-years of an obscure star in the constellation of Ursa Minor, known as AC Plus 793888.
Which leaves us with this final, truly profound thought. Long after the brilliant engineers who saved it are gone, long after the massive antennas on Earth have stopped listening entirely, this resilient, vintage machine will still be out there. So who or what might one day find that golden record drifting in the dark tens of thousands of years from now? It is humanity's permanent golden footprint in the stars, preserved out there thanks to a brilliant 45-hour hack. Keep exploring, and I'll see you in the next explainer.